Cognitive computing is where I believe very strongly that we're going next. Does that mean that everything else is going to disappear? No. But just like the DOS operating system, it will linger in the background, and so will legacy databases, and so will legacy search. And they'll be very useful, but they won't be what people are used to using in 5 years. Search becomes part of that new landscape, and a very key part of it. People interact with information in such a natural way when we exchange it with each other. And we've been trying to create systems for the last 50 years that somehow or other offload the hard stuff, which is also boring and repetitive, and still help us to do our jobs better by managing the information in the background. But as you can see, even though there are overlaps, people, context, technology, and information all do different things. And pulling those together into a single system has been something that we've been trying to do for a very long time without terrific results. So now that we have the hardware that makes it possible, now that we have robust technologies, now that we understand what some of these information interactions are all about, it's time to move on to a different kind of computing, something that allows people and machines to work together in easy, intuitive ways so that people don't have to adapt to the demands and the strictures of the machinery, but rather have that machinery adapt to the needs of the people. What is cognitive computing? We hope to find out. This is an, I think, unusual initiative. I've asked about a dozen luminaries from the search, the machine learning, the database, the visualization corners of the industry to come together to help me define it. Over the next couple of months, I've sent out a draft, happy to send it to any of you, and ask for comments. We will post, we hope, a good definition on Wikipedia and broaden the discussion, probably by the beginning of the summer. Right now, that working group has representatives, including the 3 people who are here, from CustomerMatrix, HP, SAS, IBM, Decision Resources, Electron, Basis Technologies, TextWise, EMU, VA Insight, Google, Bing, Pivotal, and Madison College. I hope there will be more. Our plan is to first define what cognitive computing is, and second, to start to conduct some research. What's the market look like? Where is it going to go? What are the trends? What are the things that we need to know? What kind of research needs to be done in order to make this effective? Let's move on to what, in our draft, we say the core elements of cognitive computing are. First of all, this is aimed at information-rich environments, capable of integrating many heterogeneous sources. And you've certainly heard a lot of discussion about aggregation, about federated search, about normalizing data. Able to synthesize answers and ideas and derive insights or make decisions. Second, and this is really important, it has to be a dynamic and adaptive system because business and life itself moves and changes very rapidly. We can't rely on 2-year-old snapshots or 2-year-old or 10-year-old taxonomies to portray the state of what we know today. Third, it has to be highly integrated. All the modules have to contribute to the system to help us understand our errors, to learn new information, to correct what we're doing. Many people would say this is a Bayesian approach to information. And that brings me to the next one. It has to be probabilistic and predictive. It has to find similar but also approximate matches as well as exact matches. It has to predict the probability of a good match. It has to find patterns in relationships. It may return ranked answers based on the strength of a match. It may also provide predictions based on facts, relationships, and events when it's appropriate, and as these events change. A good example of this kind of statistical prediction is what they were doing in order to find the missing airliner this spring. Because as new information came in, they reanalyzed the data that they had and changed their best prediction about where the airliner was. This is a new kind of statistics. It's not what they were teaching when I was in school. But it is the way people think, right? Goodness knows you're not going to analyze the world based on your 3-year-old self and what you knew then. People are probabilistic by their very nature, or they're very boring. Next, it's meaning-based. People speak language. We need to teach our machinery to speak our language rather than learning to speak it. And that's very important because language is nuanced and enriched. It's also very ambiguous. And it's a tall order to get a computer to understand what we mean, especially if it's not just text but also speech. And let's also remember that increasingly we have a lot of rich media that we want to incorporate into this. And finally, it has to be highly interactive. It has to provide the tools and interaction designs to facilitate human-computer interaction on our terms. So, with that, let me turn this in a minute over to our panel, but I want to relate this back to why this is coming up at the Enterprise Search Summit. Because all along, we know we have had something pretty special with the search architectures and tools and techniques that we've developed over the last 40 or 50 years. So why is search so key? First of all, fuzzy matching comes out of the search world. If you think beyond the search box, fuzzy matching is what these systems do. They give you the closest match, not just the exact match. And that means you're going to find S. Feldman and Sue Feldman and Susan Feldman if we all live at the same address. Next, dialogue and interaction are required to define the information need. And we're not very good at that in search, but we keep trying. I hope that we will improve this as we get into cognitive computing. We need to disambiguate the text and look at clues from context. These are things we do now. We look at linguistic patterns that are predictable and computable. We look at syntax, we look at dictionaries for meaning, we look at semantics, we look at sentiment. All of those things are not really suitable in a database environment. We use relevance ranking and confidence scores to manage large sets of results. This is a technology that is aimed at ad hoc information access, and we create information pipelines, which are very familiar even to the database world. It looks like ETL to them, but we have metadata extractors, connectors, normalizers, taxonomies, and controlled vocabularies. This is the basis for cognitive computing, but it isn't the only part of it that we need to emphasize, because all of the old business intelligence tools, as well as new AI techniques, machine learning, need to be incorporated in order to allow us to organize, aggregate, manage, access, analyze, and act on information. We need every tool in our arsenal pulled together, working together, in order to create real cognitive computing. So with that, here's our panel. All of my company insisted I put my book up here, so here it is, The Answer Machine. I run Synthexis. I've been in the search industry for longer than many of you have been around. And then I would like the rest of the panel to introduce themselves.
Hi, my name is Craig Reinhardt, and I am responsible for IBM strategy in healthcare around an initiative we call Smarter Care. I don't know how you guys are going to introduce yourselves, but
we'll come to the book.
And that basically involves leveraging technologies like the cognitive variety that we're going to talk about here, as well as others, to bring new solutions to market. IBM, as you may be aware, cares very deeply about this space. We've been investing in this space for quite some time around technologies. Likewise, we think the future's pretty bright here. And what excites me about this is I now see a way to solve problems that have not been solvable before. And that to me is really, really interesting. And it's not about a technology or a collection of technologies. To me, because I'm not a technical guy, I'm a business guy. And I look for what are the problems we can solve. And I see real problems that can be solved for the first time. It doesn't happen that often. And I think Sue's right. We are at the threshold of an important time. And everyone in this room, just the fact that you're at this conference is an opportunity for all of us to capitalize on this. So I think this is an important initiative. Sue's, I think, done us all a big favor in getting this session on the agenda and giving us the opportunity to share ideas around this topic. So, Keith, do you want to come up here?
So, Keith Mounier, I'm the co-founder, CEO of CustomerMatrix. Just to, in terms of background, I spent 10 years in the search space. From my personal experience, I've seen search projects, and I think you've experienced the same thing, getting smarter and smarter, more and more strategic for the organizations. A while back, search was about internet search and 10 bootings. And then I've certainly seen my previous company, projects become a lot more sophisticated, having semantic analytics involved, or auto classification, or connectivity of structured and unstructured data, very advanced visualization for end users, targeting specific goals, Excel goals, for example. So you're seeing these things happen in the companies. When you take a step back, you're starting to realize that there's something pretty fundamental happening that we call cognitive computing. And in fact, that's why I started the company, CustomerMatrix. We don't want to compete head-to-head with IBM on customer care, but we are targeting that use case. We are seeing, for the first time ever, with these type of technologies that you described, the ability to help customer care agents or a salesperson detect useful explanations and useful recommendations out of text, out of behavior information, and help them anticipate things like a customer at risk of churn, or a customer intent of buying something. And that is something that historically has been extremely hard to do without the type of technologies, search-like technologies that allow you to make sense out of structured data.
So Nature, I've been in the search space since, I guess, 96 now, if I count backwards. In those years, I spent about 7 of them with Fast, a search technology company that was bought by Microsoft in 2008. And then after that, I did a stint with a company that specialized in audio and video search, using techniques to extract metadata around spoken word audio. Think about video content. Well, those of you in my last session will have heard this. It's a challenge to search video and audio because it doesn't have the textual information. So my interest in this space is it's something that I've been interested in since I really got into search. It was pretty clear to me early on that there's this opportunity that lives at the intersection of search technology, which is mostly about returning records or documents, and data mining, which is a technology space that's been around since as long as search has been around, but it's on its own track. The intersection between mining structured databases and search technology is the space that I would call cognitive computing. Sometimes in the old days we might have called it text mining, but I think it's more than that. I think that the applications that transcend search, things like question answering, fact discovery, decision support applications across all the domains that these guys have talked about, is a really powerful area. And with the technology that's emerged not only in kind of traditional search space, but also the technologies like Hadoop and just improvements in hardware that allow us to do things at a scale that we've never been able to do before, are making it possible to realize these applications that I think even just 5 years ago were not possible. So I think it's a really interesting space and very timely to kind of start this consortium.
I've asked each of the panelists to bring a use case, which is cognitive computing, at least embryonic cognitive computing, so you can understand why this is important. And also I'd like each of you to talk about why it's different, why it matters.
Characteristics are, to me, and I alluded to this in my earlier remarks, is that we could do something now that we couldn't do before. And what excites me about this, I think about all of the piles and piles and piles of documents that can't be assimilated because there aren't enough human beings to throw at the problem. Think about all of the bridges and dams and airplanes that have thousands of safety reports, thousands of documents that if we could only unlock those documents, we could tell which bridge was going to fail next and do something about it before the bridge actually failed. Think about all the bills on Capitol Hill and which ones will pass and which ones won't, and which of your congressmen are voting their conscience versus voting their political alliances, and what you might choose to do with your vote the next time around if you had better information, because you could unlock what's in those bills and correlate it to something that was meaningful to you personally, right? So that the topic of meaning comes in here. Meaningful is irrelevant without context. Think about your doctors and the fact that there's more medical information published every single month than they could possibly read or assimilate, much less apply to your care, because it's all unstructured in journals. And there's too much information. So to me, the thing that these all have in common, and there are many others, is the fact that cognitive computing can unlock all of this and apply it situationally and make it relevant when a decision needs to be made. And that wasn't possible before, and it's possible now. And we all have an opportunity to shape how we interact with these systems and how we make it relevant and how we make it meaningful, and it'll be through initiatives like this. But it's a pretty exciting time.
So, as I mentioned earlier, the use case we focus on is actually targeting customer care, agents, salespeople. I'll give you the example of a project we're working on with financial advisors. Traditionally, a search project that we do for financial services industry would be about unified information access. Let's give these people all the information about their customer in one place, unified dashboard so that they can make sense of what's going on with the customer. But with the cognitive computing layer, on top of that, you're actually helping that agent synthesize information. So it's not just about showing the data and accessing the data. It's about extracting that piece of news or that key factor event about that individual. Birth of a child, marriage, divorce, big promotion, that will help the financial planner decide, is that someone I should be calling as a priority? Another example, not so much on the semantic side, but more on the behavior analysis side, is looking at parameters like movement into the account, in or out, website visits, whether the person clicks on the information that I sent or not. And look at any deviation of that behavior, something that tells me a story of someone who's no longer going to be a customer of mine, someone who actually is interested in buying more assets from me. So there's a lot of intent that can be predicted of log files, behavior data. And so when you look at this unstructured data and make sense of these weak signals that we as human beings would do naturally when we look at a 360 view of a customer, cognitive computing is that assistant that helps you synthesize these screens, and it becomes particularly helpful when you're managing 100 accounts to have an instant understanding of some of the things you should focus on for that account.
So going back to Sue's definition, I thought about this. There was an application that I worked on with a team about, I guess it was 12 years ago, and I was just dating. I don't know if you guys remember when Google first put out their API. So they made it possible to interact with the Google Index programmatic, so you could write applications around it. And when it first came out, I had a boutique consulting company, and the team had some time, and I said, let's see if we can do something with this API. It's essentially, it's the index of the entire World Wide Web, accessible through an API. How powerful is that, right? We had this idea, actually several ideas, but the one I thought was most relevant here was the content on the web includes, among other things like movie reviews and reviews of products. And we said, if we can access that information and apply some cognitive intelligence to mining those movie reviews, can we get a machine essentially to develop an analysis of all the movie reviews and come up with a generic way of providing reviews of movies in the aggregate of the content on the web. So essentially we use the Google API, and actually it comes back to one of the questions that Sue had about pre-processing, which I think we'll talk about later. We use the Google API with a pre-built index already set up, and asked it for a collection of movie reviews for a particular movie. Use that to run through a sentiment engine. You're familiar with sentiment? How many people know what a sentiment technology engine is? Okay. So for those of you who aren't, essentially what it does is it looks for words and phrases that are indicative of opinion or intent, but in this case opinion. And came back and was able to apply a model to generate a score for those movie reviews. So if it was something like Lord of the Rings Part 1, it would come back and say, of these 30 reviews, we're going to analyze the sentiment of each of the review. And some of them will be slightly positive and some will be slightly negative. We'll come up with an overall review. So the way that system works is using a Bayesian convention to calculate sentiment, and it used a training-based approach. So humans had an input example positive reviews and example negative reviews. Not just about Lord of the Rings, but just examples of those different types of reviews. And it would build essentially a Bayesian model to say if any movie review comes in with these concepts or words or phrases, and they're generally adjectives and adverbs, by the way, hated, loved, awful, wonderful, it would come up with an overall score. And it would say with some probability this movie review is a positive review. And I'll be damned, that thing worked really, really well. It worked really well if it had enough training data. And the point here is that you can use existing data structures, in this case the entire index of the World Wide Web provided by the Google API, with some semantic processing of the results, and generate an application that actually has some value and is able to create automatically an understanding of the content that's out of the web. So that application can be applied to customer service use cases as well. And another quick example is the same concept applied to transcripts of customer interactions over the phone to an agent. I know there's at least one example I know where there's a company doing that to understand whether agents are staying on script, whether the agents are being nice to the callers, and whether the callers are happy or not calling in to complain. And in this case, because it's using an audio transcript, it's able to use the actual words in the transcript, as well as, and I know at least one case where they're using the acoustic properties of the voice. Are they yelling, or are they being even keeled? So there's a lot of features that you can borrow on, and it's fundamentally all cognitive computing, because it's trying to analyze and be intelligent about the information.
Imagine a 6-year-old boy. He lives in Minneapolis. He is of Latvian extraction, let's say, and he has cancer of the brain. They found a tumor of a particular type. How do you treat him? Well, today what you would do is you would look up the drugs that target this particular kind of tumor, and you might read how it was used to treat, 60-year-old Asians and 40-year-old women, and et cetera, et cetera, et cetera. If you look at all those elements of cognitive computing, including the role that big data plays in it, what we have is the opportunity to create an information system that has sucked in all of that medical information and then has finally divided it so that you can find other cases of 6-year-olds with that particular kind of tumor, how they were treated, and what the outcomes were. So we're starting to get back to personalized information, personalized business. We can look at micro segments of the population, and we can interact with the system and say, no, we actually don't like that opportunity to take this drug or whatever. What are the other possibilities? We can re-rank that information. We can look at confidence scores and recommendations before we arrive at a treatment which is agreeable to the doctor, the patient, and well recommended by the system, which is a lot different from the blind trust that we are asked to give the medical establishment today. The idea that if we have a platform, say a cognitive computing platform, it can answer questions, or it can also find patterns and surprises. And those are two very different uses of essentially very similar technologies, but it's the stuff that you layer on top that gives you the accuracy for question answering, or the scale and speed for pattern detection and surprise detection. And that's goodness. Yeah.
On this thought of a cognitive computing platform and AI and all this, first of all, I reject the notion that it's even a platform. It could be a set of services. Platform is a word that we're building one called Watson, which is a cognitive computing platform. We're spending $1 billion to do it. But that said, that's because we see a business opportunity. That said, it's not a platform. It's a set of capabilities.
They're highly integrated.
And they are highly integrated, but the platform has certain big hunking connotations that I don't know necessarily need to be true. And perhaps that's a debate that this consortium needs to undertake. But to me, it's less about intelligence and more about meaning. And meaning is situational, and it's your meaning, which is different from my meaning, which is different from the next person's meaning. And to me, the real trick is not how do we get to artificial intelligence. To me, the real trick is how do we make information more meaningful than it has been. I don't know about you, I'm sick of getting emails from vendors who think they know what my buying preferences are. Right? Because of something I bought 2 years ago. I can digress for a moment. I'm a football fan. I'm originally from Baltimore. The Colts left Baltimore in 1984. And I'm a Ravens fan now. I get emails from the NFL thinking that they want to sell me Colts memorabilia. And it sends me off the deep end every time. That is not cognitive computing. Right? Sorry, but this is the point, right? They'd be a lot more, to take your example, they'd be a lot more effective with me if they sent me Ravens emails, and they're never going to sell me a piece of Colts.
What you're saying is the city's more relevant than the team.
It's situational to me.
It's relevancy to me.
But this is where the opportunity is. The opportunity is to make this more meaningful. And to me, solving problems like this, it's not the act. Other people will probably want to debate this with me, but it's not about artificial intelligence. It's much more about how do we make this more useful, more relevant, more meaningful. And where's the value in that?
I do recommend you pay attention to this trend of cognitive computing. A fancy name, but I think it's a very profound trend from the search space of seeing how things in search have evolved for the past 10 years. I think this is very significant. I recall meeting recently one of the founders of Data one of the first few to coin the word big data back in 2009. And look what that trend is today, that category is today. I think that cognitive computing is about that next major trend. It's not about big data, it's about, talking about what you said, that meaning and ultra relevancy, but filtering that information so it's useful to the people doing the work.
Yeah, I'm very lucky that I work for a company who's been very public about how important this space is. I mean, we've said we're spending over $1 billion on various aspects of cognitive computing. And this is an exciting time. And I'll just recap what I said earlier. I'm thankful that I know Sue and I'm able to participate in this group because I think this, it's a unique opportunity that comes along where those of us who have an opinion on such things get the opportunity to influence the ways that this can potentially go. And I'll just leave you with this. It's not every day you go to one of these conferences and something comes along that allows you to solve problems that couldn't be solved before. That's what we're looking at right here. So hopefully you will all embrace the challenge and especially work with Sue and get involved in this initiative if you have an opinion or this is something of interest. Because big things are coming. 80% of the world's information is unstructured and is not being leveraged the way that it could be. And that's what the opportunity is. We can now get at the rest of it that we've been ignoring for far too long.
With machine help, because we're looking at building new kinds of architectures that are trying to mimic the brain and make connections in new ways. And that's really exciting. And that's also part of cognitive computing. So I urge you to go to my website for now, synthexis.com, and take a look at what I've got there under cognitive computing. Send me email, send any of these guys email. We would really welcome your input. By July, I expect to have our final draft up on Wikipedia. You're welcome to comment there, but also be part of the building of this. So let me know if you're interested. Thanks very much for coming, and I appreciate it.